This podcast is entitled Stoichiometry Introduction. So, as the title indicates, the definition below it, we look at stoichiometry using numbers. Quantitatively, we are going to figure out how much, whether it's volume, mass in grams, or later we might ask the question about concentration. But in any event, stoichiometry does look at the numerical analysis of chemical reactions, trying to determine ahead of time how much starting material do we need, how do we mix them in what proportion in order to get the desired product. If you think about it, anything that you make, you probably need to, before you begin it, assemble the materials that you are required to use for the process. So let's think about something simple, such as making brownies. I've got a box of brownie mix here in front of me, and what I have is some directions on the back of the box that tell me the proportions in which to mix the brownies. So if you think about it, I need a brownie mix. I need some water. It tells me how much water to use. I need some oil and some eggs. And what they say is that once I make the pan of brownies and cut it into the desired sizes, I will get 20 brownies. Well, let's say I'm going to make not 20 brownies, but I want to look at how much stuff do I need, how many ingredients do I need if I want to make 50 brownies. So instead here, 50 brownies is going to require some more ingredients. Now we could just simply multiply, but I want to take this idea and go back to our use of dimensional analysis, and then we can apply that forward to chemical reactions and the stoichiometry using chemistry. So bear with me for a minute as we go through the ingredients that you need for making brownies using stoichiometry or using dimensional analysis. So if you remember from dimensional analysis, what we needed was the given and what we want to find. We also had to put our given over 1 and then write some equalities. So in this case, in this problem, we want to make 50 brownies. We want to know how many eggs that are required, and the relationship that we need to consider is the proportions in the recipe, which said that for every 20 brownies we needed 2 eggs. Where did I get that? Well, I got that in the original recipe on the box, that we needed 2 eggs to make 20 brownies. So we're going to take our given and put it over 1. And then we're going to write a proportion of the equality that we came up with. Technically speaking, 2 eggs do not equal 20 brownies, but for this tells us the proportion to use. So that's what the equality is that we're going to use here. And then finally, doing the math, multiplying 50 by 2 and then dividing by 20, we get the answer, which is 5 eggs. So let's carry this forward to a number of other ingredients that we need to make our brownies. Notice that each time I set it up, I put the given, which is 50 brownies, over 1. But depending on what we're trying to calculate, in each case, what we multiply by will change. So notice that if we want to calculate the amount of water needed, I need to look at the relationship between brownies and water and use those proportions in my equations. And if we want to calculate the amount of oil needed, we use the proportions in the recipe for oil to brownies to get the amount of oil needed. And then finally, to figure out the amount of brownie mix to use, we use those proportions of brownie mixes to brownies, and that gives us the proper amount of brownie mix. So this works great for making brownies or following other recipes that we want to double or triple or whatever. In chemical reactions, the same concept applies, except in this case, our balanced equations aren't ratios by, um, how many cups or teaspoons or tablespoons of a substance or a reactant, but they are mole ratios. And so we spent a lot of time earlier in the year talking about mole ratios and also gram ratios. So what if we're given grams, but we've got to look at the mole ratio? What would be the first thing that we would do? You might want to stop here so you can think about that question before you move on to the next slide. We've got to go to moles, grams to moles. And you remember how we do that? What do we consult? Yeah, the periodic table. Okay? So let's take it to a chemical problem. So we're going to decompose water. If you look at this equation, you'll notice that it's balanced. What does a balanced equation show you? The mole ratio. It says that if I decompose 2 moles of water, I get 2 moles of hydrogen and 1 mole of oxygen. Balanced equations are mole ratios, not gram ratios. Balanced equations are mole ratios. So since that's the case, we can use dimensional analysis here to calculate the number of moles of oxygen that are formed when 2 moles of water are decomposed, or we could calculate the moles of oxygen if 6 moles of water are decomposed, and so on. So at this point in time, see if you can pause or the podcast, see if you can set up a dimensional analysis for the first calculation. Remembering to put your given, your 2 moles of water in this case, over 1, and then using a coefficient in the balanced equation, using the coefficients in the balanced equation. You have to decide which coefficient to use based on what you're given, moles of water, and what you want to calculate, in this case, moles of oxygen. So you're going to be comparing in A, moles of water to moles of oxygen. See if you can set it up using dimensional analysis for the first one, and then proceed on to both B and C. Then, and only then after you've tried this, should you go on with the podcast. Well, how did you do? Notice that we've put our given over 1 in the problem. 2 moles of water is our given. Notice that our mole ratio here, highlighted in green, shows the moles of water, the number 2 coming from the coefficient in the balanced equation for water, and then on top, the moles of oxygen coming from the unwritten 1 for oxygen. Also notice that I put moles of water in the denominator because I wanted to cancel out moles of water from my given. That will allow me to calculate the moles of oxygen. In each case, no matter what your given is, that always goes over 1. Your ratio comes from comparing your given, water, to oxygen from the balanced equation. Oxygen, a coefficient of 1, seen here. Coefficient of 2 for water, seen down below. Moles of water, cancel moles of water to give you moles of oxygen. And also in the third case, to give us moles of oxygen. But what if you look at problem D, you weren't asked to calculate the moles of oxygen, you're actually asked to calculate the grams of oxygen. So think about that for a moment. How would you go from moles to grams? Think about that for a minute. Try to write the next step after this. Pause and then begin again. Notice that if you want to, instead of stopping to calculate, once moles of water have canceled moles of water, I can use the moles of oxygen to help me set up the last proportion, which is a calculation that will give me the grams of oxygen. Notice in this case, the moles of oxygen will cancel the moles of oxygen here. If you notice, the first proportion allowed me to go from moles of water to moles of oxygen. And then the second proportion or equality allowed me to go from moles of oxygen to grams of oxygen. So, to review, we need coefficients in the balanced chemical equation, and if we're going to go to grams, we need the molar mass. That is only if we're going to grams. If we use moles, we just need the balanced equation, moles to moles. But if we need to know the mass or grams of a product formed or the mass in grams of a reactant needed, then we've got to go from moles to grams. And what do we consult? If we're going from moles to grams or grams to moles, you got it, the periodic table. We've got to look up the mass of each of the elements in the compound in order to find the molar mass. So, moving forward, here's an example of a chemical equation that I'd like you to write. Read the sentence, use formula writing skills. Be sure before you try to balance it that you use your polyatomic ion chart to make sure that your formulas are correct. Pause this podcast and make sure that you've got it correct before you move on. Okay, how did you do? Did you write the balanced equation? Did you notice that I put a coefficient of 2 in front of the sodium hydrogen carbonate, also known as baking soda? I have a subscript of 2 here for sodium carbonate because carbonate is -2 and sodium is +1. So we're using correct formula writing skills as well as balancing equations. Okay? You might find your baking soda lab. Pause while you look for that piece of paper before moving forward. You might look back and see what else is in there. So here's the problem. The problem is to calculate the mass of water lost when 5 grams of baking soda are decomposed. Identify your given and what you want. Try to visualize the number of steps involved. Find the mass of the water lost. Well, if you look at it, oh, this problem says the moles of water lost. What did I do? I said, well, maybe it's not so good to know to start off with a problem that's as complicated as this. Let's start off and switch this to moles of water lost. Maybe mass is a little bit too much to bite off in the first time you're doing it on your own. So calculate instead the moles of water lost from 5 grams of baking soda. Identifying your given is the 5.5. Notice that I've highlighted it. You might circle, highlight, and put the value, the numerical value below it. And then likewise do the same thing, highlighting your what you want to calculate as well, the moles of water. That'll help you focus your attention on what's important. Turns out for this problem, the sodium carbonate and the carbon dioxide are not important to the calculation. They were important to the balanced equation, though. You need the balanced equation to do this problem. So, try to set this up. What's your given? What do you want to find? How do you find the moles of water lost? That's the same thing as the moles of water produced. All right, so you're on your own. Do this, complete the work, bring it in. If you're lost, 2 things to look at. Look at your book, sections 1 and part of 2, and then also your mole map from the beginning of the year. From chapter 3, look for your mole map. They have 3 parts to it. The bottom part is stoichiometry. Good luck. Have a good day.